Just one. Which one?
First stage.
Right, prophase 1. It's the only one that does it, because you have to have a homologous pair, right, to do a crossover. You need tetrads. Remember that in metaphase 1, you're separating homologous pairs. Once you go through metaphase 1, from here on out, you don't have any pairs anymore, so it's impossible to do a crossover. All right, so here's the list of all the different types of inheritance patterns we looked at. We talked about those on lab last week. All right, just add a little more to it. Let's get down to the idea of, well, let's remind about incomplete dominance. How can you spot incomplete dominance? No, it doesn't have two recessive genes.
Yes.
If the child doesn't resemble any of the parents.
Right, if the offspring look different than the parents, then that is your giant red flag. You're looking at incomplete dominance. If one of the parents resembles the offspring, or the offspring like one of the parents, then it's not incomplete. All right, codominance, that's where you have both alleles expressing, making their proteins, and the one we talked about was blood types. I want to add a little more info for you guys on blood types. So we have an allele, right, for the A antigen. We have an allele for the B antigen. And we know the possible genotype for being type A would either be this, right, or it would be this. Meaning homozygous or heterozygous, the I indicating an absence of that gene. There's two ways to be a B, right? These could be Bs instead of As. But there's only one way to be type AB. You have to have an allele on each of those immunoglobulins, and there's only one way to be an I. You have to have both immunoglobulins that do not have any genes whatsoever. So when we look at what determines what blood type you are, what determines which alleles I have, where did my alleles come from? My parents, right? So my parents determine if I am type A, type AB, type O, whatever. You also have what are called antibodies. Now, antigens are the proteins on the surface of the cell, like a little flagpole saying this belongs to John. Antibodies, though, are like commandos flowing through your bloodstream and through your tissues. They are seekers and destroyers. Their job is to kill or help kill what does not have your flag on it. It's not recognized, it doesn't belong to you. So it makes sense then that evolution has programmed me genetically for my blood type and for my antibodies. You will have the antibodies for the antigen you do not have. You have the antibodies for the antigen you do not have. Because the antigen I don't have is foreign to me. I want to protect against a foreign antigen.
Yeah.
So let's look at this over here. If I'm type A, and that's genetically determined by my genotype, then evolution has also said, well, if you have these antigens on the surface of your cells, then we want to protect you against the other kind of an antigen, the one that you don't have. I don't have any Bs. All I have are the As. So I make antibodies automatically for this foreign protein. It's what's known as your innate immune system. You were born with a huge army already prepared for any possible, well, not any, but most possible diseases. So if I am going to be type B blood instead, if nature says we're going to put this antigen, remember an antigen is a protein on the surface of your cells. It's simply a flag that says this belongs to John. Then I will have the antibody for the antigen I don't have. Well, if I have the B antigen, which one don't I have? I don't have the A. So I need the antibody for that A antigen. So in case it gets into my system, it'll go, oh, that's foreign, we need to attack it.
So if you're type AB, do you not have any antibodies at all then?
Well, think about it. If antibodies attack the antigens that you're not supposed to have, In other words, they attack any foreign protein on the surface. Would it make sense for me to have antibodies for the A antigen?
No.
Because I have A antigens on my surface, right? They'd be attacking my own blood. Would it make sense to have the antibodies for the B antigen? No, because I got those too. So it makes sense for you not to have either one of those two antibodies.
Because you're already on.
Because you have both of them on your red blood cells. So in a sense, think of this. The way John is saying it is, you will have the antibody for the antigen you don't have. Well, I'm an A, so I don't have what? I
B.
don't have the B, so therefore I have the B antigen.
You're B.
You have the antibody for the antigen you don't have. If I have the B antigen, which one don't I have? Therefore, what antibodies do I have? Right? You have the antibody for the antigen you don't have. Which one don't I have? None.
You don't
I have no antibodies.
have.
Huh?
Do those people get sick more because they don't
No,
have
this is only for that specific protein. This doesn't fight the rhinovirus, adenovirus, or you licking the floor off of a hospital. Okay? This is only for that, and that's why your immune system has so many genes associated with it. You were born already with a preset army for a huge possible array of things you may never even come across. And then again, you might. But now, you have the antibody for the antigen you do not have. You have the antibody for the antigen you don't have. So which antigen do you not have?
None.
None, so you have no antibodies for the A's and the B's. You have the antibody for the antigen you don't have. Which ones don't you have?
You don't have none of them.
No, you don't have both of them.
Well, yeah.
That means you have both antibodies.
Yeah, that's what I meant. Sorry.
Alright, so if you're given type A blood or type B blood, you will attack those cells and destroy them.
So how come you don't have the antibody O when you're?
'Cause what is O? O is nothing. It's the absence of proteins.
Okay.
So you can't have an antigen, an antibody for the absence of, but it means as though you'll then have the antibodies for the two different antigens you don't have.
So since my blood type is O negative, then I'll have the antibodies
For the A's and the B's. So you can't get blood from anybody who has an A or
Or
a B
B.
antigen on their surface. Which means you can't get it from them because they've got both. You can't get it from them because they're the B's, and you can't get it from them. You are so fussy,
That's why you're so rare.
right? Well, that's also, that's why it's the most common blood type to give. Because what if I'm type A blood. What if I get blood from this person? There are no antigens on the surface, so who are they going to attack? Nothing. So I can take this blood. That doesn't have the antibody, or doesn't have the antigen that matches my antibody, right?
Okay.
So this person, they have both the A's and the B's, right?
It
So can a type A person get this blood? Can a type B blood get this blood?
Nobody and
Good.
everybody can get the other one.
Someone of the
Okay.
same blood type get this blood. Yeah. Could you give it to type O's? No.
Type O can only get.
Right? So these guys can give it to anybody. These guys can only get it from
If
because they don't have
A.
antibodies. Alright, now the other last little weird thing is the D antigen, same rule. The only difference is you only make antibodies if you're exposed to the antigen. You only make antibodies if you're exposed to it. So if I am A negative, that means I do not have the D antigen. So I'm going to have the B antibodies, because that's the antibody for the antigen you don't have. But I don't have a D. That's nice. I'm not going to make the antibody until my body is shown what the D antigen looks like. You have to be exposed to it. So there's a way of thinking about this in terms of language. Yes, I have the ability to make the D antibody. I have the genes to make it. So my parents gave me those genes. But I'm only going to actually turn those genes on if you expose me to the D antigen. If I am A negative, or B negative, or AB negative, or O negative.
How do you expose? What is
You have to then give me the blood type that has a D antigen on it. So if this is me, right, you have to expose me to that for my body to make these.
Oh, okay.
All right, and this is a big issue for pregnancies. All
Okay.
right, women who have their first child, the blood really doesn't cross placental barriers. But during the birthing process, carrying the vaginal tissues and such, you can actually get a little bit of mixing of baby's blood with mom's blood. So I'm gonna probably go about a minute over here. Let me just do this. So mom is gonna be A negative. That means she has the A antigen on the surface of her red blood cell, right? She has no D. Here's the baby. The baby's gonna be A with the D antibody, or D antigen on it. There's no mixing of blood during the pregnancy for the most part. But during the birthing process, some of this blood goes into mom's bloodstream. She will now make antibodies for the D antigen. But who cares? The baby's out, no big deal.
Okay.
But now comes pregnancy number 2.
She already has
And
it
she
in
has an A positive baby as well the second time. But now she has the, we'll make it like this, all right? The antibody for the D antigen. Blood can't cross placental barriers. Antibodies can. And your antibodies will kill the blood of your unborn child.
Oh, crap.
All right?
Scary.
So think about up until, let's say, the last 50 years, how many women have actually had this happen to them and they had, quote, a miscarriage, right? Or so early on that the fetus wasn't big enough to actually notice, or that the baby was killed in utero, you get sepsis and both the baby and mom die. How many have that happened throughout history? Probably an awful lot. But there's a really simple trick to this. All you do is you give mom a drug called Rogam. That restricts mom's immune system.
Torso.
And so now you're suppressing it,
Yeah.
saying don't make the D antibody, don't make the D antibody. That way the baby is safe until the baby's born. But let's say I was out in the middle of some bizarre 11-month backpacking trip, and I got pregnant on the 5th month of my backpacking trip. I come back to civilization in my 7th month of pregnancy, which would really be a miracle, by the way. Okay? And they go, you're pregnant and you're now actually killing your fetus, and we don't have any Rogam. They can do an intrauterine blood transfusions
What the heck?
until the baby's born. We can do heart surgery before the little guys are born. All right, we are getting very advanced. But the whole idea I'm trying to impress upon you is this. The antigen on the surface of your red blood cell is genetically determined. That's all across the board for A's, B's, and D's. The antibodies you have, the ability to make them is genetically determined across the board for A's, B's, and D's. Which antibodies do you have for the A's and B's are determined genetically as well. You have the antibody for the antigen, you do